Welcome to the video graphing a square root function. Here I have a square root function. It is y equals negative the square root of x plus 1, all that plus 2. Now this square root function derives from what I will call a parent square root function, which is y equals the square root of x. This is a function that we've seen before, and it is a function like any other in that if I give you an x value, the function will return a y value. In graphing these functions, what we want to be conscious of is choosing what I will call nice points. And by nice points, I mean xy pairs in which both the x value and the y value are integers. For example, for this function, if x is 0, I have a y value, square root of 0 is 0. If x were equal to 1, the square root of 1 is 1. Now I don't want to select x equals 2 because the square root of 2 is not an integer. So what I will do is I will choose a perfect square value for x. The next one is 4. And the square root of 4 is 2. And for my fourth and final point, I will choose an x value of 9. The square root of 9 is 3. Okay, and I can plot these points right here. This is my parent function. I'll just write that in there. And I can plot these 4 pairs of points. So 0, 0, x equals 0, and y equals 0. X equals 1 and y equals 1 is right here on my graph. X equals 4 and y equals 2 is here. And lastly, x equals 9 and y equals 3. I'll connect my points with a curved function, and that describes my parent function y equals square root of x. Now let's take a look at our function that we were given to graph, y equals negative square root of x plus 1, all that plus 2. We've modified our parent function to form what we can call a child function, and we've done that by modifying what happens after we have our square root, and then we also modify what happens inside the square root. What happens outside of the square root is going to affect our y value, and what happens to the function inside the square root is going to affect our x value. So we'll start with outside the square root function. And I'm doing 2 things to it. One, I'm multiplying it by -1 with this negative symbol in front, and I'm also going to add 2 to it. If we follow our normal order of operations, the first thing we would do to that square root function is multiply it by -1. That's coming from here. So I have the factor -1 multiplying my original square root of x. I'm going to place that in my table by noting that I'm going to multiply by -1. And what I'll do is I'll take this -1 factor and multiply it by all the values in my y column. So -1 times 0 is 0, -1 times 1 is -1, -1 times 2 is -2, and -1 times 3 is -3. But I'm not done modifying that. I also have this plus 2 right here. So I'm going to add 2 to my function as well. That's going to change my y value. So I'll put an entry in the rightmost column of my table where I'm adding 2. I'm going to add 2 to the blue column, the ones that I just had modified by multiplying by -1. So plus 2 times 0 gives me a 2, plus 2 plus -1 gives me a positive 1, plus 2 plus a -2 gives me 0, and plus 2 plus a -3 gives me -1. Okay, that does it for the y values, but you'll also see that I'm modifying inside the square root function my x value with a plus 1. So I can think of that being modifying my parent function by adding 1. And what that's going to do is it's going to modify my x value. But here, the modification is slightly different than on the right-hand side for the y's. For the x's, we want to do the opposite. So whereas in my function I added 1, I am now going to subtract 1 from my x values. So if I subtract 1 from 0, I get -1. Subtract 1 from 1, I get 0. Subtract 1 from 4, I get 3. Subtract 1 from 9, and I get 8. So I have completed my table. I've made transformations in that I've modified both my x value on the left and my y value on the right. And the two columns that I'm going to focus on, the ones that represent my child function, are the outermost columns. The leftmost column is my new x, and the rightmost column is my new y. And if I plot those points on my graph, this is what I'll have. My first point is x equals -1 and y equals 2. So that's going to be at this point right here in my graph. My second point, x equals 0, y equals 1, moves downward slightly. My third point, x equals 3 and y equals 0, is right here on my x-axis. And my fourth and final point, x equals 8 and y equals -1, is going to be right here. Again, I will connect my dots with a smooth curve, and that represents my graph of my child function. I will write in what the functions are on the graph for emphasis. Here's y equals square root of x, my parent function in black, and my child function obtained by transforming my parent function is y equals negative square root of x plus 1, that plus 2. Well, what we can notice is that because we multiplied our square root by negative, it's as if our original parent function got flipped over the x-axis. So it's actually decreasing, whereas our original parent function was increasing. Similarly, it got shifted up by 2 because of the plus 2, and it got shifted to the left by 1 because of the x plus 1. So there you have it, graphing a square root function.